Good evening, everybody. Thanks for your presence. So I will do an introduction, very brief introduction, in order to help our guest how it is about in this third journey of the Foros of this year. And then I will read, under the title, The Leap into the Void, this edition of the Forum program aims to make students aware of our time. The awareness of what you, students, still do not know, what you can learn, and what you can work on in the future. We recognize signs that show uncertainty and evolution towards a profound socioeconomic transformation. The eruption of the digital age, the migratory movements produced by the geopolitical imbalance, the growing threat of environmental destabilization, and the acceleration of a new world order catalyzed by the first global pandemic. All challenge us to be aware of these multiple spheres. Architecture participates in this transformation and in its different aspects, whether urban, environmental, or constructive. With today's journey, with a session entitled Evolving Technologies, the accelerated transformation of production systems, digital tools, evolving materials, global industries, or energy revolution will be discussed. This session will be led by Andrea Deplazes and Jordi Fauli, whom we thank for their presence. Andrea Deplazes is an architect from the prestigious Polytechnic Institute, ETH Zurich in Switzerland, where he has also lectured in architecture and construction since the late 1990s. He was also director of the architecture department of the ETH Zurich between 2005 and 2007. Professionally, he runs the studio Berth and Deplazes together with Valentin Berth, with offices in the Swiss cities Chur and Zurich. Deplazes is also a recognized author of architectural manuals, among with the book Construir la arquitectura del material en bruto al edificio, Building Architecture from Raw Materials to the Building, has been particularly successful. The volume, published in Spain by Gustavo Gili, has become a reference construction treatise among architecture teachers and students. Starting from the premise that designing and building form are inseparable unity, he approaches the different branches of constructive knowledge from both a technical and compositional and conceptual perspective. Jordi Fauli holds a PhD in architecture from the ETH in Barcelona, and since 2012, he has been the leading architect and coordinator of the building work on the Sagrada Familia. He is a full member of the Real Academia Catalana de Bellas Arts de Sant Jordi and full member of the Institute of Catalan Students, affiliated with the Science and Technology section. In 2010, he was awarded the Barcelona City Prize in the Architecture and Urban Planning category for the execution of the Sagrada Familia, names together with the other members of the project management teams of Gaudi's Great Temple. So thanks, Andrea, thanks, Jordi, and please, Jordi, you have the floor.
Thank you. Good afternoon.
Sí, Gabriel, si puedes apagar un poco las luces, gracias.
And the presentation is possible. Thank you very much to UIC University for this invitation. I am very glad also to be here, and also I'm very glad to share the session with the architect Andrea Deplazes. We will start the lecture with these words of Antoni Gaudí. I didn't stop until I started on the unchangeable plan of the expiatory temple with all its endless possibilities. As Gaudí said, the plan for this temple is unchangeable, defined by him in his first 15 years working in the Sagrada Familia, a church with 18 towers and 3 monumental facades and portals, a vast and complete plastic expression of the Christian faith with light and airy spaces to invite feelings of spiritual elevation. He defined the building's general design through drawings and descriptions and set out the construction program so that he himself could turn the endless possibilities into reality by building of one of the three facades, the Nativity facade. In this way, he invited future generations to do the same on other parts of the building, which he specified in the form of drawings and big plaster models. His disciple successors built the towers of the Passion facade, while the interior nave, the crossing, transepts, and the apse were built between 1986 and 2010 under the direction of Jordi Bonet. Over the past several years, we have worked to complete the sacristy, and now we are building the 6 central towers, the first of which, the Mary Tower, was finished last year. The process of turning the plans of each part of the church into a concrete reality has always depended on the information of Gaudí's original plan. When we have the original plaster model or detailed drawing, the process was to study in depth before building, to understand the laws and method of design that were to be used in other similar parts of the building. Computing technologies have been a very important tool to make the entire process possible, above all because they designed the project to be built in the future only with geometries that exist in nature, but which no architect have been used in their projects before. In addition, making detailed models based on rules and the same method was the system that Gaudí created to transmit the detailed design which he intended to communicate to his successors. He proposed that the rules and the design method of the plaster models could be applied to other similar parts, defined in his drawings and descriptions, but not detailed in models. Building the Sagrada Familia has always been a challenge. Today, it necessitates the use of the most cutting-edge design and construction technology, which has required analyzing and learning what contemporary technological construction can give us to build the Gaudí project. In turn, contemporary technology, and I am speaking principally of digital technology in relation to drawing and structural calculation, has contributed immensely to new qualities and developments of the project. The new technologies also assist the task to preserve the heritage. The Nativity facade has been digitized with a scanner and photometry, obtaining a 2 millimeters of precision. First part, the study of the original Gaudí project today. We have the data of the original project in different forms, in published drawings, in the original models, the models restored after the destruction during the Civil War, photography of the original models, the piece conserved, and also in word descriptions. Now, we have scanned all the original models to better understand the geometry of the fragments that are preserved, the dot close scanner allows us to obtain a high level of detail. We'll see examples of this process about the main facade, the glory facade. Gaudí left a model of the glory facade of the main facade. The pieces scanned were built virtually. The digital photography restitution allows us to analyze the photograph of Gaudí original models and to complete the information of the remaining fragments of the models. We can thus obtain the proportions and dimensions of the geometry and be as faithful as possible to what Gaudí had proposed. The print 3D physical models, also with plaster like the Gaudí models, is the verification of the digital models. We print physical models to the verification of the digital models. This information is completed with virtual reality. During the construction, topographic digital systems allows us to control the situation of the elements already built and the correct placement of the construction elements. The central towers, example of parameterization. The project of the 6 central towers, the central towers of Jesus Christ, the 4 Evangelist Tower and the Mary Tower, above the apse. The 6 towers located above the walls of the crossing and the apse is related to the dome of the sacristy, which Gaudí left in a detailed plaster model. The sacristy was a testing ground for the towers, both based on the same concept, the intersection of paraboloids joined by a common vertex at the top, a very resistant structure. Both are the result of intersecting hyperbolic paraboloids, 12 for the sacristy and also for the Tower of Jesus Christ, highest. 14 for the Tower of Our Lady of Mary Tower over the apse, and 8 for each of the 4 towers of the Evangelist. In this way, the same geometrical composition of the sacristy is adapted to the diameter and the height of each of the towers. At the intersection of the hyperbolic paraboloids on the exterior, raised edges emerge from the cupola, emphasizing the parabolic form that rises up to its crown. Triangular windows follow the lines which generate the hyperbolic paraboloids. The process of working was to apply the laws of the original model of the sacristy cupola to the central towers with parametric informatics program. The stone of the Nativity and Passion facades is sandstone from the mountain of Montjuïc in Barcelona, which came in different colors and shades. However, the quarry of this very high-quality stone is now closed. For this reason, we have collected stones from different European quarries of the same kind, but with different colors or shades. With a random drawing obtained by a computer program, the stones have been arranged in the tower surfaces to obtain similar effects to the Nativity and Passion facades. Central tower. That is a question interesting. Today's technology allows a new structural and construction system and offers new spaces. The dome of the sacristy was built with large mixed panels. They were composed of several layers. In the exterior, calcined stone. The next layer is a reinforced concrete slab with a an interior plan of steel to be cut with ceramic tiles. In the towers, we also wanted to build with large panels, but we wanted to empower the stone as a structural material. Gaudí planned to build the towers with 12 slabs of floors in order to support the exterior surface, as in the sacristy. We imagine concentrating the structure of the towers only in the exterior surface, without the floors. The sacristy floors contain different functions of use, but nothing was planned for the floors of the towers. We followed a process of design that led us to the definitive solution. Firstly, after the structural calculation, we planned mixed panels of stone and reinforced concrete supported by a steel structure of vertical and horizontal steam beams. After, the second, we studied the agreed steel structures. The team of architects from our office, the architect collaborators in the structural calculation, 2BMFG, and the London office of Arup, decided on a new technique, tensioned stone, with a structure of steel profiles and reinforced concrete in the corners. With this possibility, we were able to recover the structural function of the stone. First of all, we studied the structure with external tensors, and finally, with interior steel bars that allow a compression of the coursing stone when the two heads were tensed. This technology allows us to build large stone structures with very little thickness and to build with big panels. On the other hand, the overall structural system allows free monumental spaces inside, two spaces of 60 meters height in the Magi Tower and in the Jesus Christ Tower. The arboreal structures of the naves built with stone, precast concrete pieces, and reinforced concrete of high resistance support the 6 central towers. A new column, the column of double helicoidal turning, generation laws as a project method. I will explain only two or three columns as example of the system, the column that Gaudí designed. In the nave, studying the original model at the scale of 1 to 10 of the main nave helped us not only to build the main nave, but also allow us to discern the laws of structure, geometry, and composition that would help us to design the nave of the crossing and the apse. Excuse me. During the last 14 years of his life, Gaudí created a new kind of column in order to dress the columns of the arboreal structure with geometrical and natural forms that give continuity between the branched columns. He created a column that is the intersection of two helicoidal columns with the same base and with an inverted helicoidal turning. The simplest one is the column with a square as its base. The intersection of the two helicoidal turnings produce the transformation from the square to the octagon. Is the intersection, the column is the intersection of the two turning, the two helicoidal turning. And after, we can repeat, perhaps. There's the first helicoidal turning, the second helicoidal turning to the other side, and the column is the intersection of the two helicoidal turning, and is, in this case, the transformation from the square to the octagon. And after, from the octagon to the 16-side polygon, the 32-side polygon, and ultimately to the circle with infinite turnings. For example, the base could be a square, but could be also a pentagon, a hexagon, or a composition of polygons. With this system of generation, it is possible to create infinite columns. With this type of column, Gaudí joins the different columns of the branched structures with continuity. In baseless, 4 columns with a square at the base are collected by another column with a rectangle at the top, which goes to the bottom with a double turning column system to the square, and beyond the square into the octagon and successive polygons close to the circle at the base. Between the columns, the surfaces and the lines are continuous, as the nature. Rigorous application of geometry, together with years of knowledge acquired by the architects and the help of advanced 3D modeling software, have allowed us to remain true to Gaudí models, interpreting them and extending and developing the solutions in other sections. For example, in this ramification in the crossing, 2 columns with hexagons at the base are joined by a column that is the transformation of the 2 hexagons to a square and to the circle at the bottom. Gaudí designed the type of column, the system and the method that we apply in new columns, using the advantage of the application of new design informatics programs. The Sagrada Familia is a bench test for new technologies. For example, the first stone columns of the nave were cut in the 80s by using digital manufacturing following the intersection of the 2 helicoidal turnings with 2D digital movement. And after 2 decades after, a robot cut the hyperbolic and parabolic columns of the Pessian facade portico. The manufacture of stone pieces by robots allows us to cut complex geometries, gaining quality and speed, and well as to improve the efficient use of the stone blocks. The hyperbolite, skylights, lanterns, and pinnacles. In the third and definitive project of the Sagrada Familia nave, Gaudí introduced the one-sheeted hyperbolite, the arboreal structure of columns that collects the weight, allows the space to be opened between columns in the ceilings and the walls with skylights using hyperbolites. The hyperbolites, the form that you see there, but this form, the hyperbolites collect the upper solar light and direct it to the interior, diffusing it throughout. Moreover, the hyperbolites diffuse the sound and allow the use of Catalan ceramic walls in their construction by placing the tiles at the triangular pieces of trencadís along the straight line directrices or generatrices of the geometry. Computer drawings gave the information about the placement of the different elements to the builders, who also know the laws of the geometry of the hyperbolite. Probably, Gaudí was so fascinated by the hyperbolite, by its forms, design, and constructive possibilities, as well as its acoustic and lighting features, that he used it, the hyperbolite, profusely in the project of the future of the Sagrada Familia. He used the hyperbolite to design numerous elements, skylights, as we have seen, capitals, windows, domes, lanterns, the 16 lanterns of the glory facade, column shafts, pinnacles, and bells also. He took advantage of the straight line directrices or generatrices in order to generate the definitive form of the hyperbolites. He designed a very personal and clever method of work and design that could be executed. In the walls, Gaudí cut the infinite surface of the hyperbolite with another hyperbolite. After that, he typically limited the surface of the hyperbolite with star forms, using the straight lines generatrices or directrices. Any point in the surface has two straight lines passing through it and rotating in opposite directions. These lines are tangent to two sides of the circle of the center collar or neck of the hyperbolite. These lines, these straight lines, along with other similar ones, produce a pointed star to limit the surface of the hyperbolite number 3. This is the key to Gaudí's use of hyperbolites, the creation of star forms using the directrices, the straight lines. If he wanted to join two hyperbolites in walls or windows, he created star forms from points of the curved intersection of the two hyperbolites. Afterwards, he joined the two straight lines of one hyperbolite to the two straight lines of the other with a paraboloid or two planes, which fill the spaces between the hyperbolites and join them, enabling continuity. Always the same, to find the continuity. The openings in other elements, such as lanterns, to collect the sunlight, are also designed by using the straight lines of the surface, some clockwise and others counterclockwise, creating rhomboidal openings, windows. Following Gaudí's ideas, a big glass star in the top of the Tower of the Virgin of Marie Tower in the apse, it's a starred dodecahedron, the star. It's supported by a slender 18-meter high hyperbolite of reinforced concrete covered with blue ceramic pieces of trencadís. The hyperbolite has 3 sharp starred points at this tip, generated by the hyperbolite's straight lines. These star points support the glass star resting gently on top. Gaudí wanted the upper star, to be bright. For this reason, it is made of glass and points of light placed in the center of or nucleus. To finish, prototypes and pre-assembly of construction elements. On the Nativity facade, Gaudí positioned life-size plaster models of the sculptures to see the effect and then gave them to the stonemasons to construct it in stone. Still today, we make full-size prototypes of many of the new elements. A prototype allows us to gauge any technical difficulties we may face and, when taken to the actual site, give us an idea of the effect it will have both from a distance and close up, which help our decision-making of the definitive project. For many years now, we have been pre-assembling the large construction elements in their entirety in a workshop outside Barcelona. We have assembled structures measuring 20 meters in diameter and up to 18 meters height. Formwork, steel structures, prefabricated stone and concrete elements, and large pre-assembled stone pieces, which are then transported to Barcelona when all the pieces are well placed. This system allows us to place the pieces at ground level pre-assembled, ensuring that they will be fitted efficiently when brought on the site in Barcelona. With the previous complete assembly, the building process in Barcelona is more effective, safe, and accurate. In addition, the digitalization of all the elements of the project allows the prefabrication of off-site components and improve the quality of the elements and the speed of placement. The 9th of this month will mark 140 years since the first stone of this expiatory temple was laid. Over the years, people's contributions and new technical possibilities have made construction possible, allowing us to meet the challenge set by Antoni Gaudí in his project, respecting also the current structural, climatic comfort and safe requirements. Thank you.
Thank you. Okay, thank you, Jordi, for this wonderful lecture. I have listened many presentations from Jordi Fauli, and it's incredible that every time that he explains something, it's like the first time that I've ever listened it. So it was a specifically presentation for us, and I'm really thankful. I was very impressed about that. He has talked about the parameterization of the geometries, how this has been achieved thanks to our research and a reconstruction of the original models. He has talked about the materiality with this combination of stones, about the composition geometrical of towers and sacristy, that they are like a kind of parameterization. He has talked about the evolution from the Gaudí's project and how are conforming panels. Well, he has talked about the interesting, it's an amazing double helicoidal turning and the hyperbolic geometry. And finally, about the prototypes and pre-assembly elements, which is the way that everything is carrying on. Thank you, Jordi, for this lecture. And now, please, Andrea, I give you the floor. Thanks.
I'm still impressed. I had the chance to see the rooms in the towers. It's exhausting, absolutely fantastic. So I gave this title, Evolving Technologies, the subtitle Construir la Arquitectura, because as we saw, very impressive that talking about technologies is something like talking about construction. You have the means in different size and different possibilities to control, and it belongs to our profession. Whether you play with very simple tools or with complicated tools, it's always dedicated to bring out the best way of thinking about and realizing constructions. So this is what is the goal or the center of the whole discussion that we are doing. Let's start with a film.
Martin, Post 25 ist wieder frei. Das ist richtig, das will ich ja nicht einmal umgehen.
So this is at ETH. 2006.
Stopp, Ernst. Gut. Langsam.
Can we proceed? Okay. So this was 2006, more or less a coincidence that I could work together with Fabio and Fabio Gramazzi and Matthias Kohler. They were dedicated to the whole question of technique, digital techniques. And I was invited to them to do works with students. So we jumped a little bit too quickly. The students were involved by testing out, as you see, testing out working with bricks by hands. Then we introduced the robot, and I was there as a guest critic under the semester, and someone we thought, okay, it could be nice to apply the results, not only doing mock-ups, why not apply? And it was a coincidence that I had in my office exactly this job to do the winery, so we quickly changed the program and produced all the elements with the robot and the students to apply. It was the first step in to start. It's important, 2006 is an important number. As you see, it's a parametric design. Here, firstly, dedicated to the control of airflow and light. And the more value is that we had fun to produce patterns of huge wine grapes in a box by turning the bricks in a way that the shadow is doing this kind of picture on the facade. And in the night it is gluing because the light is coming through the bricks. So this was the pushing moment when we said we have to introduce our students from the first moment towards the ability to use these technologies, because it's something that will be important in the future, in education and also in our job. When we want to have experienced students, then we have to train them. So in the first year course, I have always around 350 students starting every year. So it's a huge number, but we start with them. Here in the center, you see my very smart assistant professor. It's Jonathan Benamu. He is doing the teaching of the first semester. We introduced Rhino. The second semester, we introduced ArchiCAD, not to do the plans. This is the boring thing, but to learn to modeling in 3D directly. So it's something that comes out with a lot of engagement. We have a nice printer farm that we can use to produce the 3D models. And what you see here is the result after 6 weeks of training in the first semester after the start. So it's the early 6 weeks that we have, bringing out results like this, integrating a seminary week. But as you can see, obviously it is important and it moves something that also makes fun. So for that reason, we also started in our office to say, let's use this technique where it makes sense. Not always, you have to decide where it makes sense or lesser sense, but for example here, this is the Federal Court in Bellinzona, an extension of an existing classical part of a building, where we wanted to construct shells for the court hall. Shells prefabricated, this time not in masonry, but in reinforced concrete. Doing elements that allow, again, parametric design, here dedicated mostly to the question of acoustics, to have the control and the right degree of absorption, the holes that allow to absorb the acoustics, and the forms, this kind of mountains, is to control the diffusion. This is the main goal, but by the way, it's for sure that you see more or less it looks a little bit Baroque. So it's not about forms firstly, but it's what can be the more value as well, like the wine grapes that we used in the winery. So this kind of prefabrication allowed us, we did only one pattern for one module, but it allowed us to turn these elements from the base to the top, and combining it, as you see, the elements show that what we call, what the French call rapport, on fait un rapport. This means you can jump, let's see, yeah. The joints are connected by this form, so it looks like a whole integral shell construction. And what is amazing for us there is, it's not only cladding, it's not cladding, it's an integration of everything. It is structural shell dedicated to the structure, the parallel destruction, as well as the finished surface of this hall. It's not a cladding. Normally for acoustic reasons, you have to do something soft in the end to cover, because acoustics in the end is really the main problem for every big room. But we wanted to have this kind of concrete surface and not the cladding. Only to give an explanation to this approach. Okay, we continued with the students because we found out the students are very interested to step in somehow more close to, let's say, that what we call practice. And we did something like a small architectural office. We called it the Master Studio Monterosa, where we had 14 students. I had the chance to pick more or less the best that I could find in the ETH. And we started with a project that maybe will fail, maybe will be realized. This was not clear in the beginning. And it is somewhere in the snow, in the glaciers. So it's a lot of interesting questions what to do when you have to build here. The students the project was about a lot of more complicated things than only looking to acoustics or to airflow or light. So let's say there were more parameters coming together. And I will shorten because not explain everything. We can debate afterwards. It was, again, the approach by questioning of how to shape this kind of object, what to do to understand the structure, the surface, the cutting, whatever, why this form, and why this interior structure. You see more or less the ground floor plan of the hut. How to portion the rooms, because you have, again, to prefabricate on a site where there is no road. So we have found out a lot of tests were made that we have no other chance than to use a helicopter. Using a helicopter means you have to look for lightweight construction. So the students tested out a lot of possibilities. Again, is it steel? Is it whatever you can imagine as light steel or light construction? And in the end, it came out, it's not bad to choose to do it in a timber construction. Then it was about how to maintain this whole project. Where does all the energy come from, the warmth, the electricity, and one of the key moments was when they found out we are doing a peripheric spiral staircase, because then we have something like a solar trap. The sun will shine, the light is coming in through the windows and is heating the inside space and will flow up according to the physics and flow through all the rooms. So more and more they brought together a lot of very intelligent decisions. In the end as well, the whole control of the structure, a timber construction here, now in that moment, where I can say the only two rectangular angles that you will find is here in the solar panel sheet that you will see afterwards, and the connection in between wall and ceiling. This is the right angle. Everything else is not in a rectangular Cartesianic system. So as well, they had to manage this, and it was not only to do the drawings or the 3D modeling, it was to go in connection with the entrepreneur, to exchange the data. So we entered in that what we call digital chain from the design over directly to the entrepreneur and there on the machine. As we saw, very impressive before in the works of Jordi Fauli. So there is a film. Let's run. The main sponsor was Holcim, nothing to do with wood, but they understood it's an interesting project because it's a lot of question of how to build in the future, energy, sustainable life cycle questions, and. I can't see.
The breathtaking setting of the Monte Rosa Range and the majestic aspect The breathtaking setting of the Monte Rosa Range and the majestic aspect of the Matterhorn are entrancingly beautiful. From time immemorial, they have held mountaineers and hikers spellbound. These glacial landscapes have been around for millennia. People who enjoy and protect these glaciers have a special duty. They must ensure that development is sustainable so that future generations will also have a piece of unspoiled nature to appreciate. Sustainability is also a guiding principle for Holcim. We take responsible use of natural resources very seriously. Only those who live with nature and protect it can live from it in the long term. Holcim quarries stone to produce cement, gravel, and concrete. We put a lot of effort into creating new habitats for flora and fauna in areas where we have mined. Holcim is geared up for innovation. We invest in new environmentally friendly building materials and sponsor pioneering projects such as the new Monte Rosa hut. This is the site for the rock crystal, 100 meters above the old Cabane du Mont Rose. It took 6 years to plan, and a construction team has been working here since June. The new Monte Rosa hut will be a high-tech construction and a model of sustainability. It represents a collaboration between ETH Zurich and the Swiss Alpine Club SAC, supported by Holcim and other partners. The rock is hard and time is short. The construction workers install the concrete core and a series of sockets in the rock. The foundation must be in place before the onset of winter. Construction will then start next year. 12 days later on the site, and the concrete foundation has been completed. Now the steel construction engineers are at work assembling the steel grid, the actual foundation. The new Monte Rosa hut will then be built on the steel construction next year, using prefabricated timber sections. But before that, the long alpine winter will descend. Spring 2009. Master carpenter Egon Buhmann makes a visit, and site managers and architects for the new Monte Rosa hut exchange progress reports. On his computer in the office, Bruno Schacher draws the building elements of the hut, every single one. He receives the planning data digitally from ETH Zurich. The Monte Rosa hut will be 6 stories high, built from 420 prefabricated timber elements. It will be almost self-sufficient in energy thanks to the very latest technology. Sustainability is the watchword, from construction to operation. The computer sends the data to the machine. It simulates the cut, quick check, then produces the element from Valais spruce, accurate to the millimeter. Production has been running at full speed since the beginning of March. Floor and wall elements are assembled and lined with insulation mats, and pipes are laid. Getting the materials to the building site and assembly will place heavy demands on logistics, and the weather has to cooperate. Still 4 weeks to go before construction can begin. The construction workers are optimistic. The building site presents itself in early morning light. Day 2 of construction starts. Here is the star-shaped steel grid that will form the foundation for the timber construction. Yesterday, the builders cleared the site of 2 meters of snow. Today, the timber elements for the basement will be flown in and assembled. Everything must go quickly. Time is money. Every 9 minutes, the helicopter takes the floor elements from Riffelborden to the building site, each one weighing more than 400 kilos. Like the pieces of a jigsaw, they're fitted precisely into the steel grid. By noon, the inner circle of the floor has been laid. In the afternoon, the helicopter brings the outer floor elements. Cooperation between the carpenters, pilots, and flight personnel is perfect. It's tough precision work at almost 3,000 meters. At 4 o'clock, the last of the 20 elements has been placed. Foreman Martin Bornet checks the measurements. Then at 11:30, the K-Max, a special helicopter for heavy loads, brings the first wall. Beneath the rope dangles 1,720 kilos.
Ja, aber die dürfen nicht am Friedrich hier. Kijk, oh!
Assembly takes 2 hours. At 1:45, the last of the 10 basement walls is finally in place. The basic structure of the Monte Rosa hut is up, just 3 days after the construction began. 4 weeks have passed since our last visit to the construction site. The workers have now hoisted 5 stories and the outer walls have been erected. Around 20 craftsmen are at work here now. Window fitters are now putting in the windows, specially made to withstand the raging storms that often sweep over the peaks up here. The joiners are now working on the interior. The basic structure of the first floor cafeteria with its timber beams is complete. The row of windows that acts as a light and energy trap is also in place. It's Friday morning at ETH Zurich. Andrea Deplazes and his colleagues plan the next steps. It's now all about the details, color scheme, door handles and carpeting. Andrea Deplazes and his team have produced the design for the new Monte Rosa hut with their architectural students at ETH Zurich. But what do they aim to achieve?
Hier war eigentlich für mich nicht interessant.
The mountain hut as such was not actually that interesting for me, but I liked the idea of a building in a place that of course cannot be linked to civilization in any way, or at least not to the extent that we are used to in the city. In other words, no drainage, no water, no electricity. All these requirements cannot be taken for granted. So the students had to deal again with the question of what a building actually is. How does it work? Where do we get these things that we need every day? And of course I'm certain, I'm sticking my neck out here, that it will be the best mountain hut that you have ever seen.
The short mountain summer draws to a close, but there's still intense activity on the Monte Rosa building site. Metal workers add the facade, a demanding task. The protective aluminium sheathing must withstand wind and frost. And one day, it will make the building glisten like rock crystal. The in-house power plant is almost ready. 100 solar panels on the south-facing facade will supply the house with electricity from sunlight. Now the site manager has to be everywhere at once.
It's true that everything is being done right now. We have more than 30 people working on the site. We are getting things ready for the painters, putting up fire-resistant paneling and preparing the kitchen for fitting. Doors and beds are being installed. It's the final phase.
Dawn over the Monte Rosa Massif. The new hut is still in the shade of the 4,000-meter peak. The scaffolding was recently removed. It's 8 a.m. and the start of the last day of construction. The terrace is still not complete. The carpenters fit the last planks. The final spurt on the building site. Only a few hours to go until the hut opens. What's the last thing now for you to do?
The very last thing is to clear up, clean and generally organize everything.
And is it a success? Has everything gone well up to today?
I haven't discovered anything wrong so far. I have walked through the building a few times already, but everything appears to be as it should be, according to the plans.
We also take a tour of the building. We take the cascading staircase to the upper stories. The washrooms. The hut has 14 wash basins and 4 showers. There are 18 rooms in the hut with beds for 120 people. Still 29 hours to go to the opening. Work is complete. A sunny autumn day begins. The new Monte Rosa hut is complete and will be opened in 5 hours. The tables in the large dining hall are laid. Around 100 invited guests are expected to arrive in the afternoon and will be the first to spend the night in the new Monte Rosa hut. This laboratory was financed with the help of sponsors who paid 2/3 of the more than the 6 million francs it cost to build. Meinrad Eberle, he launched the project in 2005 to mark ETH Zurich's jubilee. What does he hope to see the new hut achieve?
I think we can stop here.
This project will motivate many people to come more often to the mountains and find pleasure in the world up here. It will ensure that the technologies in the building will be used in more projects. And I hope too, of course, that aesthetics...
He's not here. Okay. Okay, so the interesting thing for me was what was possible to do with students. All the projection was done by the students. And then, only to say, I had the chance then to choose two. The best student and my best assistant became project leaders. So we could then work out also the realization planning that is not possible to do in that amount with the normal course in a semester. Okay. 2012, 6 years after Gantenbein, 3 years after Monte Rosa, the ETH, the Institute for Technology and Architecture, was founded at ETH, has grown from the first start with a small cabin and one robot, and became to a very prestigious institution where a lot of devices were now assembled to test out not only the technologies, but what is it about? It's about experimentation, it's about doing new experiences and chances to take with new means. It's about doing case study projects, mock-ups, and a lot of applications possible with any kind of construction typology. I mean, it's about masonry, about concrete, about timber construction, steel, you name it. And it was really nice to have also under this umbrella of the institution very, very smart experts like civil engineers like Philipp Bloch and Joseph Schwarz, who were as well members in this institution. We have integrated the building physician questions and other important, let's say, core competencies that we have to assemble when we want to work in architecture. So we see some works that came out in different scales and under different occasions, only to give an impression. Some structural works, others dedicated more to building physician, always under the title that we want to find out something. It's not to, and this would be the big misunderstanding, it's not to optimize industrialization in the boring sense of making the things only cheap and quick and fast. So when you saw the film of Gantenbein, would be a misunderstanding that the robot should do the interesting work and the student behind is feeding the robot with this boring kind of laying the bricks towards the robot. So this is important to understand. We are not, it's not in our interest to push that line. So some applications, some strange things tested out. We have no idea, maybe it is something, maybe not. We will see. But it's open to test out. I mean, as long, we don't want the students to have any pre-knowledge than without testing out. And there's a lot of interesting topics behind lightweight construction, even in the heavyweight field of concrete and whatever. And we know that, for example, when Holz in 2009 said we are dedicated to the green architecture, we are interested in that and that, like the film, the propaganda was done, we want to see it. We want to know how do you make the concrete CO2 free. Now I'm very happy to say that I think we have some solutions that are very, very close to that goal. For example, so more and more, I see this institute as the chance, dealing with the core business of that, what we are doing in architecture when we are designing, conception, and as well trying to overbridge into the building site, into the construction, into the materiality knowledge, to bring that together under one umbrella. So this is my last slide. this is not, this is something that is going on now. We found out that it would be very interesting to do the same here in Spain, to found a new institution, exactly, let's say something similar to the ETH that you saw, maybe not starting so big, but ETH was very small 6 years ago, before 2012. So we start, and the new Spanish Institute for Technology and Robotics and Architecture is founded. It's legalized, it's founded, it's financed, it's located in Pamplona. In April, we will start with refurbishment of 2 industrial halls to transform them into the testing rooms to work on, like we saw examples in the ETH. So this is only to announce, let's see, maybe this is from interest afterwards in the discussion to explore a little bit more what does that mean. Okay, thank you very much.
Okay, thank you very much, Andrea. Andrea, he has been talking about, he has prepared a presentation about the evolving technologies, how evolving technologies gives us the possibility of geometry and measure. He has shown us 2 videos, the first one with ceramic panels. He has been talking about what they are doing the first year of in their university, that we invite all your academic dynamics and activity, to be honest, and how young students, they begin to work with modelization. He has been talking about Rhino, not for plant, just for 3D modelation, something that maybe we could talk about. And now with this wonderful video of Monte Rosa, I think that there's not the need of summarize anything. I think it was everything explained on that views. And the most important maybe is the integration of system, not only about the construction in an extreme conditions. It's an interesting evolution of the growth of the ETH Zurich and how they are generating creativity and not a boring systematization with the elements. So he's talking finally about the integration of knowledge. And well, with this great news, he announced the new Spanish Institute for Technology and Robotic Architecture. Thanks, Andrea, with this wonderful explanation. And now, as you know, we have a few minutes because we have to finish at 9 o'clock, but we have still almost 30, 40 minutes to introduce the debate. As you know, we have some students, but here in the audience, teachers, Vicenzo, Teresa, or Jaime Valle, or David Puig. He's an architect, a great architect from the team of Sagrada Familia. You may contribute with your participation. Okay, who's going to be the first?
A question mark. Should we not go before this bar a little bit closer to the
we can
public? I mean,
yeah, we can go there. We can sit there.
I would like to, if possible. Yeah,
we can go there.
Okay. Huh? A discussion has to be close.
Hello, okay. I'm Mariana. I was really interested the speeches that you said, like mostly about the construction part, because I don't know, personally, I see more about the plans and sections and the modeling, but not the constructive. So I think this question is more focused on Andrea. Ooh, I'm sorry. So how do you think could technology play a role around efficiency and constructive methods in a country that does not have the resources?
Maybe I did not really good understand because of the mask, sorry.
Yeah, no, maybe it was my English. I can repeat it. So how could technology play a role around efficiency and constructive methods in a country that does not have the resources?
Okay,
Yes.
okay. So this is another kind of very interesting topic that we can say it's not about, I'm not meaning that we have to push anything in this direction of high technology. I think we have to be very, very clever in applying the possibilities, the resources that also are existing. I mean, if I would be working in a country where people are able to work with handcraft to bring out a lot of qualities, but maybe not having robots and so on, that I think is not the problem. We can, I mean, but as I found out, most people have something like a phone, even if anything else is not existing, but the phone is something that more or less is in the pocket. And knowing that, I would say we have several possibilities to go forward on. For example, in the field of augmented reality, not to having the machines and the high industries and a lot of money to spend, but maybe to give small entrepreneurs the chance to operate very direct on the building site without any plans, because they have the smartphone and the right program to, let's say, learn how to assemble several modules to a structure, which is ongoing. And I think this is something interesting. We want to empower the chances. And what I'm interested in general is not to make the piano narrow. I don't want to have high technology only. I want to have a broad field. The piano should be as large as possible so that we can use better and more of the chances and the means that is implicated in this approach. I don't know, I never had the chance to do something in South America, but I could imagine that there, the question is totally different from that what you show now in Switzerland. In Switzerland, you never would be able to pay the people doing the handwork because they are too expensive. So you have to be more efficient on integrating the tools of machines and digital means. While maybe in another country, exactly that is not the problem, and not the efficiency of the cost is not the problem, because you have a lot of knowledge and a lot of good people able to do something. So I would say we have to be very careful we have to do differentiations. I'm against this kind of general black and white technique is maybe a problem or maybe a danger. So should we do resistance or not? We should learn to treat with the means to make the best out of it, but also being, let's say, in a several kind, also critical. I mean, when I saw this film of Monte Rosa, I had to laugh in myself and say, yes, this was then the newest technology, but it's still 12 years ago. It looks for me a little bit old-fashioned, huh? On one side. On the other side, I say, it's not about to push and push and push. We have to find out what could be worse. I'm totally against, and you interrupt me if I'm talking too much. Huh? Sorry. I'm totally against this kind of people, more or less, somehow of managers that say industrialization has the goal to make the process fast and the cost cheap. This is one side to see industrialization, but if you have only that in mind, then I agree, then we lose the capacities and the possibilities in architecture to be resistant and to have this field of ideas that we want to follow. So we want to push people with good ideas and not bring them on the piano to only one octave to say, now you have only to play the 3 tones and finito. I stop here because I think there is a...
Yo tengo otra pregunta para Jordi Fauli sobre la Sagrada Familia. ¿Cómo podemos establecer un diálogo entre el proceso de construcción y los materiales usados en relación a la época de Gaudí y hoy en día?
En síntesis, los materiales son los que propuso Gaudí. O sea, los materiales que utilizamos, por ejemplo, la piedra. También el hormigón armado, que también lo utilizó Gaudí en la fachada de nacimiento, en sus terminales. Materiales similares o los mismos, pero con la técnica de hoy día. Hemos visto la piedra tesada, por ejemplo, o hormigones de alta resistencia. En síntesis sería, el material es el que propuso Gaudí, utilizaremos materiales en los pináculos de las torres centrales utilizando los mismos similares materiales que los que utilizó Gaudí, pero evidentemente utilizando la tecnología de hoy día y lo que nos proporciona la técnica de hoy día. Los morteros, materiales de mayor resistencia, con mayores controles de calidad, etc.
Mi pregunta también es para Jordi Fauli y quería saber cómo han conseguido seguir siendo fieles a las ideas de Gaudí sin tener todos los bocetos completos de la Sagrada Familia.
Bueno, un poco intentar explicarlo, ¿no? Porque tenemos muchos bocetos de la Sagrada Familia, tenemos muchos. Gaudí estuvo 43 años en la Sagrada Familia, estuvo los últimos 14 exclusivamente en la Sagrada Familia y dejó mucha información para el futuro. Información en planos del conjunto del edificio. Información de partes importantes detalladas en maquetas de yeso a 1:10, escala 1:10, escala 25, por lo tanto con mucho detalle. Y explicaciones que recogieron sus discípulos y publicaron. Y en estas publicaciones, antes de la destrucción de las maquetas en el año 36, estas publicaciones incluían fotografías de las maquetas, los planos del proyecto, etc. Pero además, Gaudí planteó toda su construcción siguiendo un código, unas leyes de composición concretas de unas formas geométricas, que nos permite este código conocido, nos permite interpretar mejor las maquetas, aunque sea a partir de las fotografías, y diseñar aquellas partes que él no llegó a detallar, pero que sí definió en dibujos, pero no al detalle, siguiendo este mismo código, estas mismas leyes de composición. Gracias.
Gracias.
Hello. Well, thanks to both of you for very inspiring presentations. So I have a question for every one of you, but I will start with Andrea. So Andrea, in your role of professor, do you still think that being architecture such a wide field makes sense that it's just architecture as career, as comparison with engineering, that you have many specialties, many different fields, and do you still think that being a generalist is good for learning architecture?
I think both. I think you will have both if you want or not. It's like in the medicine. You have the specialists for the heart, for the liver, for whatever you can imagine, for the brain, and you have those who are more or less have an idea about the whole organism. And if the problem is really something very special, then they send you to the specialist for the brain, for example. So it will not be, we cannot avoid that in our discipline, in our profession, there will be a specialization on one side. For example, not every student that I had would be, in my mind, a good architect, but maybe a very clever technician to drive the whole digital processes. So this comes out and we will have a spread of new specialization. I think this is, you can't avoid. It will happen like that. On the other side, we know exactly that if you have only to do with specialists, who is doing the orchestration of that all? So how to, I mean, if I have to do with my really fantastic colleague Dillenburger or with Arno Schlüter, building physicians, or even with Philippe Bloch, you have very experienced, smart experts in a several topic, but they would not be able to do the whole work going further on to say, okay, now let's start through and we have to integrate all these topics to become a piece of architecture. And in the end, or in the beginning, I would say if you have no idea about the project itself, then I never would dare to start. And this is something that I guess we have to have in mind. Somehow, I mean, the generalist, this word can be very old-fashioned when we understand this like this guy who has the total control and He says it has to be done like this, and if it's not like that, then it's a terror. I mean, we have to learn for sure for the collaboration with that kind of experts. But I have to be honest, I could not do a project alone. It's impossible. Even not as architect, I have to integrate a lot of know-how coming from outside. The question is, do we give up this kind of quality and this kind of understanding architecture as something that is a self-standing discipline? Do we think that is more shifting to sociology or to other directions that maybe also are touching architecture, but maybe we have to decide at several points what is really belonging and establishing the project itself, what is from importance, from what value, and maybe what is only interesting but not necessary. To explain it, now you know that with digital processes you could do parametric design with 3,000 parameters if you want, even more. But it's clear you can't understand 3,000 parameters. It's a question of calculation, it's mathematics. You always will get a result. If you feed 3 parameters or 3,000, for the computer it's no difference. You get the result even with 3,000. The problem is that if you don't value the 3,000 parameters in before, saying what is really from an importance or what not, you will get the result. And there I see the mistake or the misunderstanding. It's not the result, the best solution. It's more or less the how do you say, the mediocrity of, like in a democratic system, that what is coming out when everyone has to say what should happen. You will have a decision making, but maybe it's not the best solution. And I think this is a big misunderstanding that even I see with some colleagues. They believe, like in God, they believe that the parametric design will solve all the problems, which I'm really doubtful. But on the other side, giving up to try to understand the architecture as a body that belongs together with all that important things would be like giving up the profession. So I would always support someone who tries to be a generalist, always. But I would not do obstacles for someone who said, my life is this kind of digital means, I like it. My assistant doing this course for the first year and doing in the upper semester course, he's a fantastic guy. He is always very humorous and doing perfect. If you want to see, you can go in the net looking his tutorials. Fantastic, fantastic. I know that he is fantastic in that field. I would say, I hope he is not hearing now. Maybe he's not the best architect. Maybe he should not do buildings, but he should do exactly that, what he found. To be some kind, like a clever bridge. I mean, look at me, I'm old-fashioned, I'm over 60. Do you think I have any idea about this complicated stuff? I never will learn that. The young people are able to do that, and this is the chance. If you ask me, I would say yes, if you are young, you should learn these tools. You should not avoid. I mean, to be very hard, nobody will wait for you if you are not able. That does not mean that you have to embrace it without any critical mind and say, now it's like it is, and Silicon Valley says that the world is be saved by all the big giants that we have. We have to be critical, but smart. Huh?
Thank you.
That's
Thank
it,
you.
more or less.
And I have one for Jordi. So Jordi, what's next? I mean, don't get me wrong. I know you have a lot of work to finalize the Sagrada Familia, but I mean, it seems like a pity that all this know-how of people, processes, programs, talent could be lost when this is finalized and everybody's dispersed. And with all that know-how, it could be done something else, build something else, or create something. That's my question.
We are in the finish for the moment. But I suppose the people that have been
formed in this architecture in the future could communicate this knowledge to other buildings, to other projects. And also, we have the duty to explain our work to the people in order to diffuse it. No? I'm not worried about that, but I am, I suppose David also, I am convinced that the architects that are working in the office, if when the works finish, will be prepared to work very well in another projects. I profit also this answer to explain that I agree with your last opinion. No? And about the paper, the role that need to do the architect. As a person that in all the construction process have clear the aim, the way, and the architect must explain, must give the opinion above all the collaborators in order to arrive to the synthesis, and a good synthesis, not a mediocrity. Thanks.
Maybe. What I learned today when I was with you up in the Sagrada is if Gaudí would not have given several genetic code for the building, how to proceed, you never could do it. You would not be able to follow. Now you have the rule, you very nicely showed what is the secret of the geometry behind that, what we see. And it's like suddenly you understand, it's like a genetic code of the whole building that you can now understand why it's that and that and that way. Huh? And I think this is according to that what you asked. The generalist is maybe the guy who has has really in mind the conceptual part. That's something that holds together. Conception means holding together. Otherwise, if you don't have a conception, maybe something like a code, then we have the problem that all the specialists are doing parametric design. They throw in the knowledge and hope by mixing the algorithms, you will have a result. And naive people believe that this is also the best one, which would be a fundamental error.
I agree. The project is not the sum of the collaborators. The architect must push all the collaborators to produce the maximum, and the maximum in the line of the objective.
Sorry.
Sorry, no, you can go first if you want. No, I was just following the order. Well, hi everyone, I'm Thibaut. First of all, thank you for the presentation. I thought it was very interesting. The question I prepared tonight is directed at Andrea, I would say. So given the speed at which technology is developing, what future do you foresee for us architects? How do you expect us architects to collaborate with technology in the future?
Somehow, when I'm at ETH and I see the students and have the impression it is a very normal process. It's not new in that sense. It's only an enlargement of, let's say, tools that allow to do new things or different things. But what I also see is it's not replacing other things. It's not the goal to replace everything with digitalization. The students are doing as well cupboard and cardboard modeling, and we say always hybrid models, so different materials to test out. You take the best. So you take, let's say, like opportunistic approach, you take the best that you can with the lowest amount of work to bring out a result. Something like being smart and efficient, but for sure. And for the students, as I see what is happening, it's not so far a problem to proceed. It's more or less for the older people to understand that, yes, times are changing. Times are changing. That's the constant continuity, and what makes life constant is it's always changing. So I would say there is a chance, we could find chances and nice opportunities to bring out new ideas that you never would do. I mean, you could never send the bricklayer to the building site and say, now you have to twist the bricks and you have to do this plan with every position of the brick. He will send you a letter and say, you're mad, do it yourself. And on the other side, it's a very archaic technique. Masonry is wonderful, it's fantastic. Why should we give up? What I found out, in the moment when digital procedures came up, suddenly Masonry was re-actualized. Before, everyone said, Masonry, it costs too much. Why Masonry? Let's do in concrete. The student, in the 90s, I did not see any Masonry project at ETH. Everything was done in concrete. Now you have a different approach and suddenly the students say, oh, it's interesting, timber construction, how to join things. And it's not about to imitate something or to do the same thing like they had to learn. They test out, they're doing, maybe some things are failing. Okay, nothing happened as long as it's not the building. So I think it also opens chances, and if you approach it I would say open-minded but critical, then you are on an interesting track. And for whatever will happen in the next 10 years or 20 years, nobody will give you a guarantee now what exactly will happen. When we would be asked in 2006, well, what will be happening in 10 years and 15 years, I would not have seen that what I could show now.
Yeah, I think honest, a lot of people think maybe technology, they view technology as the enemy, but rather they should see it as a complement to what we already have, our human resources. So, yeah.
There are new questions about resources, about sustainability, how to deal with concrete to avoid the CO2 problem. Is it now forbidden to use concrete or not? Or should we do, what should we do? Okay, we could do lightweight constructions to use lesser concrete. Maybe this is interesting as long as, in the moment, someone has invented really the concrete without CO2. Last week, I read in the newspaper in Switzerland, a firm in Switzerland has brought out a patent now with a concrete that is absorbing the CO2, not only from the production, but even more. So maybe this is a first key for a solution. And if this would be a solution, maybe the whole discussion about how should we use concrete or not is suddenly over. Maybe we could stay critical and say, nevertheless, we could think about new combinations of materials that brought up when more and more the interest was given to spot for sustainability in construction. Why we see, okay, timber constructions are very interesting because exactly of that questions. So why not combine steel and wood, or concrete and wood? Things that before nobody have thought about it. And yes, I saw someone ask about, will there be people losing the job and whatever? Yes and no. Yes, there will be winners, and yes, there will be losers, and yes, there will be people somehow in a conflict not being able to avoid, and what to do. Shall we now follow like the sheeps behind the leader, or what?
Mm-hmm. Thank you, super interesting.
Unless you really want to go. Hi, so I had a question following on from what we're talking here about. I guess it's about influencing the construction industry and whether you think that these evolving technologies are going to remain sort of, I guess, boutique versus actually having a flow-on effect that really can resolve the climate crisis that we currently find ourselves in. Do you think we're influencing them as a whole, or going to in the future?
We are, and we are. We are influenced, and we are influencing.
Yeah.
We cannot step out. But I would say I know exactly as much industries which I had to work with that I could say, yes, they are really interested to have these collaborations and finding out new rules, new possibilities, exactly like others, they say, listen, we know what we are doing, so what would you say as an architect? Huh? Why are you competent? Why are you more competent to say me what I have to do? I would say this is the chance for also for those people who are really interested in, let's say, thinking about what could be interesting solutions in the future. And there is a potential, there is a chance. I mean, you never will convince 100% of people. This is not possible. In democracy, not. And I would say this is normal. So nevertheless, this does not mean you have to give up. I think as an architect, as young architects, waiting for the best chance to step in the practice, doing something interesting, you have to be active. Only that, you have to be active to proceed. Maybe you have a club to say, okay, let's do new experimentations. Instead of, I always say to the students, I think it's better that you become architects than politicians, but maybe you could be political architects to understand that you have in your hand maybe solutions of the discipline that you can bring in and not the politicians who has no idea about architecture. So we have not to being confused to choose the wrong field. I would say architects are architects, but if they're really working in a good way, they are able to bring out solutions that are very interesting and needed in the debate, without any guarantee of success.
Thank you so much. Juan, did you have something to say? No?
Maybe I could also, before then it ends, I could a little bit explain the new institute, Spanish Institute. But if you have important questions.
Yeah.
Excuse me, we have 8 minutes left.
Okay.
Because they are closing at 9 o'clock.
Oh, we are closed in?
Yeah.
So we are doing a cluster. If we stay, we could prolong the whole night.
I have a question for Andrea. I was listening to the lecture. I thought it was really interesting, but the thing that came to my mind was like, okay, now that we're moving on this time that we have all this robotics system that we can implement on the projects, when you start to design a project, do you start thinking on, okay, I have this concept, for example, of the light or how this will turn inside of the building? Do you start thinking on the project at the same time, taking into account this robotic help? Like, okay, I'll do this, because I know this robotic system can produce this shape or can do this kind of stuff. Or rather, you start designing a concept, an idea, and then you say, okay, I want to design this. How this robotic system can do my project or my idea. Do you think you're being the design, it's been conditioned, yeah, by the robotic system, by this new technology, or is it helping it?
I think this is going in the direction of understanding it as a general question, as a generalistic question. I can only talk for myself, what I am doing. I'm not thinking about robots when I start to think about architecture. I think about architecture, I want to have a conception, a clear conception that I like, that I could follow as an idea that is hopefully strong, convincing as well, because you have to start to convince your clients and convince whoever will engage. And I'm not asking about, is this the moment where to think about robots. By the way, robot is only one tool. It looks always impressive, this kind of man-like machine that has nothing to do with human. So you have other important and interesting technologies that you could use. But I would say, I would never let me drive in advance to say, I have now to integrate all these tools in my office, and then let's look what is coming out like happening. Because I think this is exactly what we have to learn. It's only a tool. I want to control the tool. I don't want to be controlled by the tool. But understanding that a computer is only a machine, it's only doing what you are saying. It's not doing nothing itself with a not yet. Huh? I did not see this kind of intelligence that is really coming self-standing. Maybe somewhen, I have no idea. But in the moment, I would say it's about controlling that tools. And okay, if it fits here, because it opens several possibilities that could not be done in another way, then maybe I'm interested. When I'm talking with entrepreneurs, let's say carpenters, people, timber constructionists in Switzerland and carpenters are very experienced. I mean, the field of timber construction is the most developed field of digitalization in the building process. And there you have people where I'm suddenly sometimes amazed of propositions that are coming. I say, could we do this and that? And the timberer says, well, yes, but we could do it like that, and why that, and how that, and okay, we use this and that machine to do this and that. Wow, I also am learning, but I never would say start with the tools, and you could, but it's not mandatory. But okay, sometimes there is a need, like I never would say you start, how do you start when you're doing a design process? You start with an idea, you say, I found out that a lot of students at ETH do a very silly thing. They think they can only do design when they have a program, for example. I say, no, why do you need a program? I mean, a functional program. Huh? Why do you need that first to be able to do design thinking? Or you need a context, a clear context, otherwise you can't do. Where does this come from, this very narrow idea? You could start, as we saw here, Jordi Fauli showed how to think about dealing with stone, pre-stressed stone. Wow, okay, it is possible to start with the material, to come to the result. It's possible to start with a program, it's possible to start with a site. You have to evaluate the value of that, what you start. You can't do parametric design and say, if you are cooking, you can go in the kitchen and say, okay, let's take everything I have together. Hopefully we can eat it. Or you go there, looking around and say, okay, now it's about the pasta. So maybe this and that, and combining with this and that. And the very good cookers are even combining things that we, stupid, are astonished. Say, wow, look, this combination. But they never would mix it. So parametric design is not an arbitrary mixing of something without thinking. If you use Pinterest, Pinterest is proposing you a lot of interesting information. The whole world is on your phone, and you always get information even if you don't want. Nothing is valued there, nothing. It's only formal similarities. I got a comparison in between New York City, a photo from the air, and a canyon in the same algorithm, because the surface was similar. It has nothing to do. I did not ask for a canyon, but the computer cannot. I mean, it's not human being, sorry to say. And for that reason, I would say, you have to be critical. You have to give the things that you're doing a value. Is it important? Is it very important? Is this project driven more and more from that and that part in question, and maybe not so much from the site, or not so much from... This is important. Otherwise, you really give away the control and you can mix. And there are people they are doing, believing that the result is the best one that you can get. The minimalized compromise. I'm not so interested in that.
Thank you.
The Sagrada Familia is a sample that Gaudí thought in a parameterization without existence of digitalization.
Yeah, for example.
It was in his mind.
I mean, we say parameters nowadays. We could also say, what are the influenceful, really important things to integrate, qualities or special questions? If you are building a house in the far north in a very, very harsh climate, I think, okay, building physics is not unimportant then. I would not skip it out then. But maybe in another situation, it's not so important. So. There is, unfortunately, no cooking book to follow the rules and say, okay, let's cook now a business house or an office building, or you can, but this kind of typology, believers, is the same. Typologies tend to fix patterns that are so-called given by the tradition over generations, so they have more or less a huge experience. That's true, but it does not allow you to be uncritical to say, because it's done like that, we only copy it. You have to, nowadays you can't take anything as granted. This is the complicated thing of our life. This was much more easier in the medieval time. There was whether the church or the ruler who said what has to happen.
I don't know if we have time enough for one more question. It's 9 o'clock, so from teachers maybe is a question, or we can do it here. I mean, it's a very interesting conversation, Andrea. I think that we could follow afterward, but yes, I
Okay.
require to finish. This is like a Swiss watch. It's a university.
Obviously, it's dangerous. Yeah. Okay, and about this institute, you will follow, we will have news, you will read it in ongoing this year. If everything is running like it should, we open 23. Okay.